In fact, even before we see types of vectors, there was something that was important to see, and that was representation of a vector. How is it denoted? How is it represented, both mathematically and in the three-dimensional form? Let us look at all of that. So, as I already told you, anything which has a magnitude which is represented by its length and a pointed arrow which shows the direction to which this length is pointing to, that is your vector, right? So anything of this sort is a vector. So how are vectors denoted? So usually vectors are denoted as something like this. This can be thought of as AB bar or some A bar, right? So whatever your vector's name is, you write the name, write the symbol, whatever it is, and you put an arrow on top of its head, right? That will actually not just give a name to this vector, it will not just give a name to the vector, but also signify with this arrow that okay, it is a vector, right? This arrow signifies that it is a vector. If I do mod of this, if I make these two make these two lines around this vector, I call this mod of a vector. And what does this mean? This will actually give me the length of AB. So I'm calling this vector as AB. I'm not calling it as A. I'm calling it as AB. And mod AB, what will mod AB give me? Mod AB will give me the length of this vector AB, right? Always mod of anything which actually just gives you the length of that vector. So that's how with giving the name and giving an arrow on top of its head, that's how the vector is represented. Coming to a very important concept called position vector. So position vector is something that's really, when you study it for the first time, if you don't get its understanding right, everything else later, whenever you hear this word position vector, you always keep getting confused as to what this vector is, like what do you actually mean by this. So as the name suggests, position vector, it means it gives the position of something, right? It gives the position of something. But now if I talk about the position of something, it has to be with respect to something, right? So for example, what is the position of this point with respect to origin? So position kind of makes sense only when you have some reference fixed, right? Otherwise, without the reference, if I just leave anything randomly in space and I ask you its position, then what will your answer be? You should ask me, what are you asking the position with respect to? So I first have to set up some reference, and with respect to that reference, I need to check the position. So usually my reference in 3 dimension is my origin, right? The place where the 3 coordinate axes intersect. So this is your x-axis, this is your y-axis, and this is your z-axis. And here they intersect at origin. Now this becomes my reference position. This origin becomes my reference position. Now if I have any point in this 3-dimension space, for example, if I have a point here which is denoted by A, right? Its position vector is that vector which starts from the origin and goes to that point, pointing in the direction away from the origin. That is what is the position vector. So this pink thing that you see here, this itself is the position vector of A. Now, how is it denoted? It's obviously denoted as A bar. So if I tell you I have a point A, and if I tell you its position vector is A bar, what does that mean? It should immediately come in your head that okay, there is some coordinate axis, there is some coordinate system, there is some origin there. From that origin, if I draw a vector and come to my point, which was your A, the vector which starts from the origin and came to the point with its direction away from the origin, that itself is the position vector A bar. So this A bar is nothing but this pink vector. You should always remember that. Now, does it have to be origin? Can it not be something else? Obviously, it can be something else too. Usually we fix our reference to be origin, but if you want, you can take a different sort of a coordinate system, fix this as some x, y, z, right? And then your position vector will be with respect to x, y, z, right? But in our coordinate system, the ones that we use commonly, we fix origin as the reference point. So the vectors which start from the origin, point away from the origin, and go to the point of interest is the position vector of that point, right? And the position is obviously with respect to origin. So keep this in your head, like watch this again and again and keep it in your head, that position, you should exactly know when I use the word position vector what it means. This understanding will really help you. And also, if I ask you what is, for example, if the coordinates of A are x, y, and z, if I ask you what is mod A, what will your answer be? Mod A is the length of this, right? The length of this is the distance of this point from the origin. Is the distance of this point, this point of interest A and the origin. The distance between these two is your length of the vector mod A, right? So that is something like you have a point x, y, z. You have another point which is 0, 0, 0. You need the distance between these two. So you obviously know the distance formula. It's under root x1 minus x2 whole square. Your x1 is x, your x2 is 0. So it is x minus 0 whole square, which is x square. Similarly, y minus 0 square, y square, z minus 0 square, z square. So this is your magnitude of the position vector of a point having coordinates x, y, and z, right? So all of this, all the understanding of position vector and its magnitude, and you know how it looks, what does it mean, everything should be clear in your head whenever it's asked. So with this, let's complete the concept of representation of a vector and position vector. Let's look at what are direction cosines. So direction cosines also fall under this subtopic, under this category. A vector is represented in the form of its directional cosines. Let's look at what direction cosines are.